One common method in statistics for comparing multiple densities is to use a box plot. A box plot has two attributes, an x, which is usually a classification into categories, and y, the actual variable that you're mapping. So in this case, we would do ggplot of diamonds. And let's say we want to compare the color, the distribution rather, of the price between each color. We would do x equals color, y equals price, and our layer is geom underscore boxplot. The boxplot provides some information in a compact form. You can see the median is a thin black line. The edges of this box are the 25th and the 75th quantile respectively, and these points here are outliers that fall outside the expected range of the data. In this particular case, since there are a large number of outliers, you may want to try putting the y-axis on a log scale. Recall that we do that by adding an option, plus scale underscore y underscore log 10 open close parentheses. This is a better behaved histogram that gets a better sense of how the distribution of price differs across multiple colors. One problem with a box plot is it doesn't show details of the distribution besides these quantiles. This works well when a data follows a normal distribution, called a bell curve, but it might not work for stranger distributions. For example, the distribution might have not one but two frequency peaks, what we call bimodality. However strange the distribution, a box plot will always look like a square. We can instead view the distribution as a density using what's called a Violin plot. To do that, all we do is change geom boxplot to geom Violin. The width at each point in this Violin plot represents the frequency of that price. So these bumps show the prices that are more common, and we can see that indeed within some colors there is bimodality. There are multiple points that are more common, so that a box plot did not represent. Just like in scatter plots or histograms, if we want to see whether another variable is involved, we can use facet wrap to divide our plot into multiple subplots. For example, we could divide this into subgroups based on clarity. To do that, we would do plus facet underscore wrap tilde clarity. Now you can see that we've divided it into 8 smaller Violin plots, showing the distribution within each of those levels of clarity.